This is group 35. I'm Omkar, this is Anisa, and this is Adrian.
This is part 1, lab 1. This is the schematic for circuit 1. This is the truth table where X is the where X shows the output for the circuit 1. As you can see, if A and B are not pressed, there will be no output. No output. If only B is pressed, there will be an output. If only A is pressed, there will also be an output. If both of them are pressed, there will also be another output.
Okay, this is the circuit analysis of group 35 for the circuit 2. As you can see here, these are the results for the circuit 2 represented by Y for the inputs A and B. A and B are represented by these two switches, while the output is represented by this LED light. Now, after plugging in all the wires that has to be done, we can now carry on to see if this truth table follows the experimental values. Now, as you can see here, if A and B are not pressed, there is no light showing, and this is shown by here. But if only B is pressed, we have a light showing. If only A is pressed, there's a light showing. But if both A and B are pressed together, there should be no light showing. Okay, it's showing, but okay, you press this other button. Yeah, so you can see there's no light showing, which proves that our truth table follows the experimental values. Lab 1, we are group 35, and we have to measure the TPLH, TPHL, VOH, and VOL. As you can see, using the oscilloscope, we have figured out that the VOH is 3.28, while the VOL is 80 millivolts. And while you try to find the delay, you can see that TPLH is 42 nanoseconds as shown here from the oscilloscope. So that concludes our part 2 of lab 1.
Done?
Now a quick review of part 2, in that the typical delay is 9 to 18 nanoseconds, and the total propagation delay that we got was 42 and 44. 42 was representing FRR, while 44 was representing LRR. Now we have to divide by 4 because we're using a 4 NAND gate as a series of inverters, and we get 10.5 and 11, which is within the typical range. The VOH was 3.28 and the VOL was 0.8.
This is group 35, part 3. In this experiment, we're proving that the LED only works at a low state. So by default, as you can see here, when we're not pressing the button, the input here is at a low state. And since we're using a NAND, it inverts the low state into a high state, which is why the LED, as of now, it's not working, it's not lighting up. But if we do press the button, like this, we convert the input into a high state, which then inverts into a low state, which allows current to flow and the LED will light up.
Right. This is the part 3 calculation in which we have to find the resistor. And the resistor is found by the use of the VDD, which is 3.3, the VF which we are given is 2 volts, and the VOL which is 0.1. The resistor value we got is 120 ohms. But this circuit does not meet the intended operating conditions for the gate, and this is because from the data sheet the VOH should be at 5.2 milliamps, but it does not result in damage because there is a resistor that reduces the current flow, so this prevents the 10 milliamp from damaging the gate. Part 4 of our lab 1, and as you can see from the schematic here, we are using 2 input NAND gates and 1 3 input NAND gate. Now this is how the layout is set. We have used only one IC for the 3 NAND gates, the 2 input one, and we've used one IC for the 3 input NAND gate. Now As you can see from this truth table, for only when 2 buttons or more are pressed, that's when there should be an output. If 1 is pressed, there should be no output. So let's see if it works as with the truth table. 1 button, it doesn't work. 2, it doesn't work. The third input, it doesn't work. But if you press, for example, A and C together, there's a light. If you press A and B together, there's a light. And if you press 3 of them together, this is C, this is B, there's a light. And if you also press A, there's a light. So this shows that our truth table coincides with the
Circuit.
circuit.